This is lesson 4-4, Probability, the basis of insurance. Our quote is, "It is a capital mistake to theorize before one has data." And this is Sir Arthur Conan Doyle. He was the author of the Sherlock Holmes books. The objectives in this lesson are to explain how to interpret two-way tables, to compute conditional probabilities based on two-way tables, to determine if two events are independent, and to interpret and create Venn diagrams. Again, there are a number of key terms that you need to know the definitions of in this lesson. Let's go over them. First of these is actuary. This is a statistician who provides information about risks in financial situations and assists insurance companies in setting rates. This is why insurance companies always tend to hire math majors, because they need people to look at the statistics and assist them in setting rates and seeing what are good risks and what are bad risks. The next is probability. This is the possibility that an event will occur. Next, event. This is the outcome of an experiment. Then we have two-way table. This is a rectangular array used to depict a relationship between two variables. Then we have conditional probability. This is the probability that an event will occur given that another event has already occurred. So if another event has already occurred, what's the probability that this event will occur? Conditional probability. It's conditional upon the other event. Independent events describes two events in which the probability of one occurring is unaffected by the occurrence of the other event. This is the opposite of conditional probability. Associated events, this is a set of events which are not independent, okay? Associated events, a set of events which are not independent. And then lastly, a Venn diagram. This is a pictorial display in which sets are represented as circles enclosed by a rectangle representing the universal set. So let's look at our example number 1. A pail contains 7 red, 6 green, 3 orange, and 4 black marbles. 1 marble is to be drawn at random. What is the probability that the marble is red? All right, so if we add up all the marbles, we end up with 7 plus 6 plus 3 plus 4. In other words, we've got 20 marbles in the pail, okay? 7 of these are red. So the total is 20, and 7 of them are red. So if I reach in and grab one, the probability of picking red is simply 7 over 20, or 0.35, or you could say 35%. Let's look at example 2. A factory is planning to rearrange the parking spaces in its parking lot to better serve the employees. The employees work in 3 different shifts and drive 5 different types of vehicles shown in the two-way table below. So this is a two-way table, all right? So we got the 5 different vehicles: 2-door sedan, 4-door sedan, SUV, truck, motorcycle, and we got morning, day, and night shifts. So the first question is, what is the probability that a randomly selected employee is on the night shift? All right. So how many employees are on the night shift? 59, all right? And what's the total number of employees we've got? 246. So if I pick one of those employees, what's the likelihood that he's going to be on the night shift? Simply 59 divided by 246, which is 0.24 or 24%. That's the likelihood that you will pick somebody on the night shift. Now, we're using the same data, but now we're asking, what is the probability that a randomly selected employee drives a motorcycle and is on the morning shift? All right, so let's look at the morning shift. The morning shift is this row right here. How many drive a motorcycle? Well, 4 of the morning shift drive a motorcycle. So we're going to select somebody at random. 4 drive a motorcycle and are on the morning shift. Again, there are 246 employees, so 4 divided by 246 is 0.02 or 2%. So the key word here is and, all right? So we're driving a motorcycle and we're on the morning shift, all right? So that's only 4 people out of 246. So here's another question, again relating to the same table. What is the probability that an employee drives a motorcycle given that they work the night shift? Okay, so we know they work the night shift. So here's all our employees who work the night shift. So we know we're in that group. And how many drive a motorcycle? 5. And how many are on the night shift? 59. So 5 divided by 59 is 0.08, or 8% of the people drive a motorcycle and given that they work on the night shift. So they work on the night shift and drive a motorcycle. Okay? All right, let's look at example 3. Justin is doing a statistical analysis to check if sports cars in his town are involved in more accidents than other types of cars. He polls 315 randomly selected parents of students in his high school and gets the results shown in the table below. Does the table support Justin's theory about sports cars getting in more accidents? All right, the first thing we're going to look at is what is the probability of any car getting in an accident, all right? So we've got a total of 315 cars were polled. How many were in an accident? 150 were in an accident. Okay, so I simply take 150 divided by 315, comes out to be 0.48 or 48%. So 48% of all the vehicles were in an accident. Well, now we have to look at, well, what's the deal with sports cars getting in an accident? All right, so sports cars are right here. Here's a column for sports cars. How many got in an accident? 50. And what's the total number of sports cars? 105. So 50 over 105 is also equal to 0.48 or 48%. So does the table support Justin's theories? No, it does not support his theories, because basically what it's saying is that the probability of a sports car getting in an accident is the same as the general probability of any other vehicle getting in an accident, 48%. All right, let's look at example 4. Jenny is judging a classic car show. She's also preparing a report on the cars in the show. There are 135 cars at the show. 70 of the cars had a manual transmission, 43 had air conditioning, 13 had both a manual transmission and air conditioning, and 35 had neither. A car will be selected at random to appear on the cover of the report. What is the probability that the car will have air conditioning but not a manual transmission? So the first thing we're going to do is create a Venn diagram. And this is what we have here. All right, now, let's look at the numbers here. There's 135 cars in the show. So all these 4 numbers, 57 plus 13 plus 30 plus 35, has to equal 135. And I think you can see that it does. Now, 70 of the cars had a manual transmission. So this circle on the left here is going to correspond to a manual transmission. And if you look, 57 plus 13 is equal to 70. Now, 43 had air conditioning. So this circle on the right is going to correspond to air conditioning, AC. It says 43, so if I take 13 plus 30, that's 43. 13 had both. And that's this number in between, the intersection of both air conditioning and both manual transmission. That's 13. And 35 had neither air conditioning or manual transmission. And that's this 35 here. So everything outside the two circles did not have manual transmission and it did not have AC. So the question is, what is the probability that the car will have air conditioning but not a manual transmission? All right, so we want air conditioning but not a manual transmission. Well, 13 have air conditioning and a manual transmission. 30 have AC but not a manual transmission. So what is the probability that a car will have air conditioning but not a manual transmission? Well, there's 135 total, so 30 over 135 equals 0.22, or simply 22% will have air conditioning but not manual transmission. So let's take this same problem a step further. So what is the probability that a car has air conditioning given that it has a manual transmission? All right? So we're saying AC, we know it has manual transmission. What's the probability that the car has air conditioning as well? Well, 13 have a manual, are in the group that has manual transmission and has air conditioning. So what is the probability that it has air conditioning given that it has manual transmission? So we're only dealing with this circle here, all right? That's the only thing we're dealing with, since it says given that it has a manual transmission. How many of these have air conditioning? 13. So it's 13 over 70, 0.19, or simply 19%.